Can you hear me?
Yes.
Great. So, welcome everybody. My name is Emanuele Zattin and I work for Realm. And today we're going to talk about annotation processing in Android, which is something we use all the time, but not many people actually know how it actually works and what lies underneath. So let's take a look. First of all, I want to thank the organizers. I think they did a great job, and I feel very welcome here, and I'm having a great time and lots of very nice sessions. I've been learning a lot. Let's start from the beginning. What is a Java annotation? This is the official definition from, well, I guess it was from Sun, but now it's from Oracle. But basically, an annotation is a form of metadata, and basically it allows to add data to a program itself. And they don't have any effect on the actual operation of the program, but they actually add data to the program. So what can you do with them? You can provide information to the compiler. An example of this is, for example, the override annotation that you use when you override methods. The compiler is able to tell that if you're using that annotation and the superclass doesn't have the same method, then it will throw an error. Same things happen for other annotations like deprecated and so on. It allows to process data at runtime. So at runtime, you can query and ask which classes have this annotation. And then you can do compile time annotation processing, which is what we're going to talk about now. How you define an annotation? It's actually very simple. This is the simplest annotation you can write. And basically, you use this interface keyword, and you define the name of your annotation. And you use it like this, as you already, of course, know. Annotations can accept arguments, of course. You can use strings. You can do all kinds of things also with arrays. And you use them like this. The thing that's a bit off-putting sometimes is with arrays that you have to use curly brackets like this. It's something that you always have to look up when you don't remember. But other than that, it's pretty straightforward. Annotations can be annotated as well. One of the most important annotations is retention, which tells where the annotation is visible. Is it visible only at compile time, or is it visible at runtime? For what we're doing now, retention class is enough. But if you want to be able to actually query annotations at runtime, you have to use retention policy.runtime. Another important annotation is target, which tells to which kind of object or classes entity annotations can be applied to. So these are 5, but there are way more actually. So you can attach an annotation to an annotation, or you can attach an annotation to a constructor, to a field, to methods, to variables, and so on. So there are several options here, and you have to choose the right one. So if you add an annotation and you say it's only valid for a field, you cannot add it to a class, of course. Other useful annotations are documented, inherited, and repeatable. Repeatable means that you can actually add the same annotation more than once to the same entity. And inherited means that if you apply an annotation to a class, for example, then the derived classes will actually receive the same annotation processor as well. So here's a very simple annotation. We say that we want to be able to make this annotation available at compile time, and it can only be applied to classes, which in this context they are called types. And it accepts 3 arguments. One is a string, one is an integer, and one is an array of strings. So it's pretty straightforward. There's nothing crazy here. It's very simple. So the next question is, what is an annotation processor? So it's basically a technique or a set of tools that allows you to intercept these annotations at compile time, and you can do all kinds of things. You can produce compiler warnings and so on. You can generate source code, or you can even generate bytecode if you like. And it's all defined in this JSR 269, which came into light in Java 1.5, but got better defined in 1.6. One example is, for example, the inherited annotation we saw before. You can only use that from Java 6 and on. You cannot use it in Java 5. So how does it all work? So the compiler, Java-C, it just starts to go through the code and compiles it. And then it somehow figures out, we will see how later, that there is an annotation processor to go through. And so it does the first round of annotation processing. And the first round of annotation processing might actually generate new classes that are also annotated. And so you might need a second round of annotation processing. And this process goes on for, well, it can go on infinitely if you're not careful. So how do you implement an annotation processor? This is the main class that you need to know about. Of course, you can either use the interface or the abstract class, but the abstract class does a lot of the boring stuff that you don't need to care about, actually. So always use abstract processor. Don't bother actually implementing processor directly. And there are several methods that you can override. The most important ones are init and process. Init actually happens in the very beginning, and the process happens for every round. So as you can see, there are a couple of classes that are a bit mysterious. There's processing environment and round environment. What's all this? So let's figure that out. So the processing environment, so it provides some tools to be able to write files and access utilities to, inspect the classes. When you are in the annotation processor, you don't have the possibility to use Java reflection or introspection, so you have to rely on this API, which frankly is quite clunky and not easy to use, but it's what we have, and it's what is supported by the compiler, so we have to deal with it. So the processing environment actually deals with everything that has nothing to do with a specific round, but with annotation processing in general. So you get the folder where you are allowed to write files, and there are some utilities here that are useful to manage classes and types and so on. The round environment, on the other hand, provides all kinds of information related to the specific round. So you can ask to the round environment what classes or what elements are annotated with this specific annotation in this round. And you see, you can either provide a class or you can provide a type element. So it's pretty flexible from that point of view. So let's try to write our first annotation processor. And it is the most useless and annoying one. It does absolutely nothing. It just writes on the screen, I'm processing this class. So we implement annoying processor, which extends abstract processor. And messenger is used for being able to write on the screen during annotation processing. And you go through all the annotations that are defined, and then you go through all the elements to which that annotation is actually applied, and then you just print the message, I'm processing this thing. So absolutely useless. But at least it tells you how to use this. And as you can see, I don't need to use init because I don't need the processing environment because I'm not writing to the file system or anything like that. So how does the compiler know that there is an annotation processor that needs to be executed? Well, that is something you have to do yourself. And well, sorry for the ugly formatting here. But basically, when you give an annotation processor to a user, you have to package it in a jar file. And this jar file contains a folder called meta-inf that in turn contains another folder called services, which contains a file which is called javax annotation.processing.processor. And this file contains the fully qualified name of the class that is your annotation processor. So in this case, you would have package name dot annotation processor in that file. So how do you actually generate code once you are in the annotation processor? Luckily, there is this library. It's called JavaPoet, and it's from Square. Before that, there was something else called Java Writer, but it's been superseded by JavaPoet. JavaPoet does exactly what Java Writer did and more, and provided a better API. This is a Hello World example for JavaPoet. As you can see, it's a very fluent API, so you keep building your classes and methods. So you define a method. In this case, it's main. You say that it's public and static, and then it returns void, and then it accepts an array of strings, and you add a statement inside that just says, hello JavaPoet. Then you define a class called Hello World, which is public and final, and you add the method you just defined, and you build it, and then you actually build the Hello World class, and then you just write it to the file as provided by processing environment .getFiler that we saw before. So it's actually pretty nice to use. It gets more complicated as you do more complicated things. As you start generating more complicated code, of course, it starts to get confusing because then you have to start to reason in terms of the code you're generating and not the code you're writing. So another option is, of course, to write some templates and to use those. If you know that your classes will all be the same for 99% of the content, then you just have to substitute some variables. So that's another option if you know that, already know that all the classes will look more or less the same. So what's next? Testing, of course. And testing in annotation processing is very, very hard because the annotation processor runs inside the compiler. So it's very hard for a unit testing framework to actually be able to inspect what a compiler is doing, and let alone even debugging that. That's almost impossible. It's very, very complicated. It is possible, though, but it's nothing that I would suggest to anybody doing, and I wouldn't wish it to my worst enemy to do, frankly. So we need help, and luckily Google helped us in this case, and they released this library. It's called compile testing, which does exactly that. The way it does it is a bit weird because, of course, it's a strange problem to solve, so they have to come up with a kind of a strange solution to solve it. But let's see an example. So first of all, it uses the truth testing library, which I don't know if any of you know, but it's actually pretty nice, and it provides some kind of nice API. So you have to basically say, you can do something like very simple like this. You can say, this is my Java file just check that it compiles without errors. So here we have nothing to do with an annotation processor. Here is just, we could be reading a file from anywhere and just doing a unit test that verifies that this compiles without errors. So this can be useful in other occasions as well. Another example, which actually tests an annotation processor. Here we actually read a file from a resource, a test resource. Here we were actually writing the file directly, since it was so small. Here we read the file, we process it with the annotation processor that we defined, and then we verify that the output compiles without error, that the hello world files compiles without error, and that the generated sources actually compile without error. And then it actually compares it with some output that we expect. This, of course, means that as you change your annotation processor, you have to keep changing also that file, which is really, really annoying, but there's no way out of it. So if you want to test your annotation processor, and you should test your annotation processor, this is the way. So no way out of that. So now we covered annotations and the basics of annotation processor. So now you actually have all the tools you need to write an annotation processor and test it. So how about Android? How does annotation processing work in Android? It works exactly in the same way, but there are a few things that you have to be careful about, and I'm going to list them here. The first problem is that the Android framework does not actually include the javax.annotation.processing package. So how do you actually manage to implement an annotation processor when you're not even access to the package? Well, that means that you have to make your annotation processor a standard Java module. So, of course, you'll use Gradle, and you use submodules probably for your application. That means that you will have to create another submodule, and instead of having it using the Android plugin, you will have to use the Java plugin, the standard Java plugin that comes from Gradle. And then a nice idea is actually to use the Android APT plugin, which probably most of you already use if you use other libraries that use annotation processing. So yeah, use that and just tell your users to do that. And what the APT plugin does for you is basically, well, it frees you from all the hassle. So it tells Gradle where to put the generated files and then where to look for them afterwards and so on. So it's actually very convenient. So that was the first problem. But now we have another problem. So we probably already defined our annotations in our library if we are developing a library. And then you have this other module that is the annotation processor. And that annotation processor, it has to be able to access the annotations to be able to recognize them. So how do you actually do that? You cannot make the annotation processor depend on the whole library you're developing. You're just interested in those 2 or 3 classes, which are your annotations. So, well, you have to create another submodule. And also, this will be a Java module, and basically both your library or application and your annotation processor will depend on it. So it's a bit cumbersome, but it's not that bad, actually, since, I mean, you define your annotations once, and that's it. You probably forget about that package after a while. So now we have another problem. Probably if you use Gradle, if you're developing a library, you're auto-generating Java docs. But you really want your annotations to be included in the Java doc because, well, of course they should be documented. So if this is the task that you have to generate your Java docs, So let's go through it. Basically, for all the variants, which normally would be debug and release, but you can have more, of course, if you like. It generates a task, and basically it tells where the sources are, and then this is the important part. So what you have here is one example of Gradle not being exactly easy to read. So as you can see, there's an equal sign in the first occasion of source, and there's not in the second. It's not a typo. It's actually how it works. So the first thing is an assignment. So you're saying these are the source folders that I need to compile and to process. The other one is actually a method. So in Groovy, you can skip parentheses if you want, if there's only one argument, and this is one case of that. And the method, what it does, it appends a folder to an existing set. So be careful about that. So you just specify which is the folder of your annotations, and then this is also a trick that you have to know if you want to be able to link Android libraries from your Java doc. And of course, you want to exclude your build config and your R file. Nobody needs to know about those. So here are some libraries that use annotation processing, and that so Butterknife, probably all of you already know that. It's basically an injector of views, and it's super useful. Dagger for dependency injection, and Dagger 2 as well. Parceler is super useful. The parcelable interface is super clunky to implement, and this helps a lot. And we use it around as well, actually quite extensively. Our annotation processing code is huge, and we have so many tests and so on going on. It's a very, very complicated setup, but it works fine, and it generates lots of proxy classes for the users, and basically a lot of boilerplate code that we don't want user to spend time writing, and we just do it ourselves since we have all the information we need to actually generate that code. So yes, it was a deep dive, and it was pretty fast. But yeah, thank you all for coming here. I hope you've been learning something, and I hope you'll start writing some annotation processors and some amazing libraries that use that, because I don't like boilerplate either. So please ask any question.